Welcome back to Command Line TV. This is episode 10, and today we're going to talk about shell scripts and permissions. But first, do we have any follow-up from last time?
We have one follow-up question. We did redirection in the last episode, and the one issue we had was that when we did this single greater than sign, it would always overwrite the files. We had one workaround which we used set O no clobber.
Right.
The question we had was, can it be turned off, or do we just have to create a new terminal?
Right. So if you set no clobber already in your terminal, but then you want to undo that, generally I think you would have to restart the terminal, and as long as you haven't set it in your bash RC where it would read it again and apply that again, then that would take us back to a default where it will clobber things. But another useful trick is that you can temporarily, like just for one command, say, I really do mean to overwrite this file as I redirect. And the way you would do that, so let's work here on an output file. So I'll just cat into output.txt, and I can say some message, and then what was it to stop the input?
Control D.
Control T, yep. So now I've got that output file, output.txt, and if I try to do that again, it can't overwrite the existing file because I have no clobber set already in this terminal. But what I can do to override that temporarily is just use greater than followed immediately by the pipe character, no space in there. And that is not a pipe, actually. I mean, the character is a pipe, but it's not the feature of a shell called pipe. It's a redirection, but the pipe just says, yes, I really mean to overwrite this file, and so now it will let you do that. This is another line, Control D, and if I look at the content of that file, it only has the second one. The first content got overwritten.
Today we'll be doing shell scripts. To start off, what exactly is a shell script? What does it do?
So a script is just a way of automating something. Whenever you have a series of commands that you might want to execute, instead of remembering to do each one independently and getting all the options right and the syntax, you can write down those commands into a file and then execute that file, and that's what we call a script. So the basic way to do that is first we create a text file, and we've learned a couple of ways to do that with whatever text editor you want to use. One of them that we did before was nano. So I'm going to type nano, and let's call this just hello. It does not necessarily need an extension. So just because it's a text file doesn't mean you have to put .text. But when it's a shell script, sometimes people will put a .sh at the end to say that this is meant to be executed with the shell. But it's really up to you what the file name is or what extension it has. So I'll do that. And now the first line of your script is very special. It always starts with what we call hashbang, or sometimes it's called shebang for short, I guess. But hashbang is the pound sign and the exclamation point. And this is a special signal to the operating system that this text file can be executed using some command interpreter. And then you put the location of the command interpreter after the hashbang. So if it's a shell script, that means that the command interpreter is your shell. So that's usually like bin sh or bin bash. Or you could even write scripts that are particular about using some other shell, like ZSH or whatever. We still haven't looked at other shells besides bash, but we'll eventually do that. So let's keep this as bin sh. It's a very generic shell. And now any commands that I type after this will not execute now, but they'll execute when I run the entire script. So I can say something like, echo is just a very simple command that allows you to put out a message on the screen, right? So I can say echo and put a message there. And then let's just, for example, say your files are, and then I'll run a command like ls. So it's just sequencing together these two echo commands and then the ls. So I'll save that Control O file name to write. Oh, it should have I thought it would get that from the command line, but I guess it didn't. So I'll say hello there. Oh. That's fine, overwrite, I guess. Oh, it's a directory. Interesting. So that's why that didn't work. I already have a directory called hello. I can't also have a file called hello. So we'll go ahead and use the hello.sh form of it. And then we can exit. And so if I ls from here, there is my hello.sh file that got created. And I'm almost ready to execute that as a script. But we have to now look at these permissions. The X permission means that you're allowed to execute something. And directories will already have executable permission because when you cd into a directory, that is thought to be like executing it. So the executable permission is what allows you to cd into directories. But these other files that are not directories do not have executable permission. I need this to be executable in order to run the script. So there's a command we're going to do called chmod. And we'll talk about all the options of this command in a moment. But chmod just means to change the permissions, which are also called modes. So mod comes from modes. Plus X means turn on execute permission, and then the file name. So now, after doing that, if I get my ls listing, you see that this hello.sh, first of all, it turned green, which means it's executable. And it has the X permission out there. So now I can run that. And to run it, because it's in the current directory, I use dot for the current directory, / hello.sh. And there it is. So it says hello world, and your files are, and then it runs ls, so it gives me the listing of the files.
So when we first made this file, you did hashbang, and then you had to specify which shell it's going to run in. Can you specify multiple shells, or is there something particular about that?
There has to be just one shell that's expected to execute this. Okay, so I can't, let's bring up nano again, hello.sh. I can't put multiple shells here or have multiple hashbang lines or whatever. But what this means is that it's telling the system that this is the shell that should run this script. That doesn't mean that you have to run it from that shell to begin with. So I could be in any shell, and if I specify /hello.sh, it will then invoke the correct shell to run it. So in other words, if I'm currently using bash, it will invoke sh. Or if I'm currently using zsh, it will invoke sh, because that's what the header said to do. And it's equivalent to, like if I do head on that, it's equivalent to taking this line without the hashbang, and then putting the name of the file you specified after that. So this is just another way to run it. It's more verbose. But it takes that shell that we specified and then the file containing the script, and it does exactly the same thing. So that's what that hashbang notation is doing for us. Also, we call it shell scripts if the command interpreter you specify after the hashbang is a shell, like sh or bash or zsh. But it actually could be any programming language interpreter. So if you're familiar with Python or Ruby or some other interpreted programming language, you can do exactly the same thing. Let's just do a quick one like that. So I'll say hello.py as an example. And in this case, I want to put the path to the Python interpreter. So instead of bin sh, my command interpreter is Python. And now, instead of using echo, I'm going to use commands that Python supports. So I can say like, print hello from Python or whatever. So I can write that, hello.py, exit, and then same thing, chmod plus x, hello.py, and then I can run hello.py. And this time, it's still a script, I just wouldn't call it a shell script, it's a Python script. But it's that same hashbang notation to do it.
So do the scripts that we write automatically have error checking built into it, or is that something that we'd have to set as an option?
It's not very, I mean, there is error checking, but it doesn't necessarily do what you want. So for example, if you make an error in a script, it might then continue trying all the rest of the commands anyway, and maybe it would be safer to just stop. So let's try that out. If I open up this hello script in Nano, and let's say I make a mistake on this first command, that I don't know, mistyped echo or something. So I'm going to write and exit, and then try to run that script. And what we see happen is it does detect the error right when it gets to line 3, but then it goes on with the rest of the script. And maybe you would rather quit. So let's come in here. An option you can set in a shell script that says basically quit on error is you just say set-e at the top of your script like that. And so save that and exit. And now when I run it, it encounters that error and tells me about it, but it does not continue with the rest of the commands. So that's probably a little safer to do that kind of detection. There are some fancier things that you can do once you learn a little more about the shell syntax. So, for example, if a certain command fails, you can then provide an alternative. So if this fails, then do this instead. And maybe the alternative command is just to issue an error message and quit, but it allows your script to be a little bit more adaptable and friendlier. But that takes a little bit of knowledge of programming and of the syntax of the shell. And we'll start to get into that, but I don't want to get that complex just yet.
So we used chmod to change the permission on that sh file that we had. We always see all these different letters, R, W, X, D, maybe some dashes. What do they all represent, and what else can we do with them?
Great. So this permission string, I'll call it, that comes on the ls-l output. I'm going to leave out the D part. That's just whether it's a directory or not. But the rest of it are these 9 characters, right? So to demonstrate this, I'm going to just open up an editor so I can just do some typing for us. So RWX, RWX, RWX. That appears 3 times. Those are the 9 characters. And of course, R is read, W is write, and X is execute. But why do they appear 3 times? Well, these apply to different classes of people on the system. So the first set of permissions is about the user. So the owner of that file, or the current user, or whatever. And the second set is about the group that owns that file. And then the third set is everyone else, which we call others. So anyone else. So anyone that's on this system, but is not the owner or the group that owns the file, right? So we saw here, I guess I will save this as, permissions.txt or something, so I can come back to it. So we saw here also in the ls-l output that this is the owner of the file and the group that owns the file. And so you can set up groups and stuff. That's a little beyond the scope of what we're going to do right now. But a user on the system can be a member of multiple groups. So you might have like different work groups that you coordinate with or whatever. So if I open that up again, the way that we specify those, so when I did chmod, I just did chmod plus X, and that means turn on all of the execute permissions for everybody, for users, group, and others. But you can also specify it in different ways. So I could say like, let's say for user and other, turn on read and execute, okay? And then you put your file name out here. You could say something like for group, turn off write and execute, and then you put the file name. So it's just this little syntax of specifying which permissions to turn on and off. And the first half of it, which is optional, is you can put U, G, or O for user, group, or others. The second half, and then you have plus or minus to turn it on or off. And then you can have RW or X for read, write, execute. But there's yet another notation that can be used for these things, and these permission strings, and it comes up sometimes, and it's actually a numeric notation using the base 8 or octal. So this is a little bit weird, but what you do is you treat each of these as a bit. So the bit is on or off, right? If it's on, we put the W. If it's off, we put the dash. So something like that. And then maybe these 3 are all off. And then underneath that, you kind of mentally put a 4, 2, 1, okay, which are the first 3 powers of 2. So in binary notation, you would use the first 3 powers of 2 here and then just repeat them over and over again. And then you end up with an octal number by just taking the sum in each group. So I'm going to like split up the 3 groups here to make it a little clearer. So for this permission string that's Rx, RW, and then blank, I would then add the 4 and the 1, because those are both on, to make 5. Okay. And then in the next group, I would add the 4 and the 2, because those are on, to make 6. And then none of these are on, so that would be 0, right? So that's a numeric representation of exactly that permission string. So let's say I did chmod 560 file name. And let's try that. I'll save this first. And we'll do chmod 560 hello.sh, right? And now when I do ls-l, I see exactly that set of permissions, right? Rx, and then RW, and then nothing. So that's 5, and then 6, and then 0. So you eventually kind of learn this numeric notation. The ones that are most common are, let's say, 644 and 755. Okay, so why are they the most common? Well, 644 means you're turning on read and write for user, and then you're turning on read only for group and read only for others, right? So this is kind of a file that can be read by anybody, but only the user can write to it. This is similar, except you're just turning on the execute bit for each of these. So the 7 gets you RWX, 5 is 4 plus 1, so that's R blank X, and then R blank X. So 644 and 755 are very common. For files where you want to be a little bit more private, if you want to make sure that like only I can read this file and nobody else, then you use zeros for the rest. So maybe 600 would be RW for me and nothing for anybody else, right? Or if it's executable, then 700. So that's RWX, blank and blank. So those octal notations are there, and a lot of Unix people know and understand them very well, but they are optional. If you're more comfortable with it, you can always just use the pluses and minuses with this other notation, and that works just fine.
So that shell script we wrote at the beginning of the episode seemed very similar to writing a program in C++ or any other programming language. Does it support features such as variables and loops, just like these programming languages do?
Yeah, the shell is a full-blown programming language. It's just kind of a weird programming language. But it's useful the way it's designed. So it does support variables and loops and if-then-else and all those sorts of things. So to do variables is fairly simple, and I can just demonstrate it here on the command line as well as in a script. So let's say that I want a variable called like x, and I'll give it a value. If you want to use text with spaces in it, then as usual the spaces should be quoted somehow, so I can go like this. So x becomes that string. So that just takes whatever value is on the right and stores it into that variable called x. And then to refer to that later on, I have to use $x. Okay, so you can't just say x. Like if I were to echo x, it says X. But if I echo $X, that means go look up a variable by that name, and it will give me the message that I stored into X. So that's a very simple example of a shell variable. There are other kinds of variables that are used in the shell pretty commonly, and they're called environment variables. An environment variable, the only difference is that the value of an environment variable is passed into programs that you execute, okay? So it can be used, for example, to control different programs in different ways. So for example, if you want to see all of the environment variables your shell is currently holding, there's a built-in that does that called env, env. So when I type this, it's going to give me a list of all of the environment variables along with their values. So you see it's got things here like what terminal I'm using. So term is the environment variable, and on the right side of the equals is its value, or what shell am I currently using? Who is the user that's logged in? Where is that user's home directory? And then the path is a set of directories that it uses to find programs. So all of these are variables that are set in the shell. By convention, they're uppercase names, but they don't have to be uppercase names. That's just usually the way it's done. And if I want to set a new variable, you notice that, for example, my $X, which I set to hello world, that doesn't appear in this list because that's just a shell variable and not an environment variable. So one way to set an environment variable is go back to that way that I set X to hello world, and all I do is I type export before it. So this means I'm setting a variable in my shell, and I can still do echo $X like I did before, but now that variable will get passed into programs that I run subsequently, and they can access that. So sometimes you'll use environment variables to configure those programs. If I do env now, you see that X shows up here as one of the environment variables. So that's just like having two different classes of variables that are used in slightly different ways. As for loops, I sometimes use loops directly on the command line as well as in shell scripts. And the simplest type of loop you can do is a for loop where you are iterating over a set of names, a set of things. They could be file names, or they could just be any type of text at all. So let's say I put for X in hello there world. What's going to happen is that any words that appear after in, but before the semicolon, will then be used to construct a list of values for X. So X will take on each of those values one at a time, right? So if I just do that, it's waiting for me to continue the rest of my for loop. Oh, I actually have to type do. Forgot about that. That do could have gone on the previous line after the semicolon. And now I can type certain commands in here, like the word is $X, for example. And then let's just repeat that word a bunch of times. And then I type done. The done matches with the do, that creates the body of my loop, and it will execute those two echo commands 3 times. Each time X will take on a different word from that list. So the first time X is hello, and it gives us those 2 lines, and then the next word, and so on. So that's just a little for loop, and you can type that in a shell script or just on the command line like I did. A common way to use it is with files. So if I want to do like star, semicolon, do. Now X is going to take on the value of every file name in the current directory, because that's what the wildcard will do. So I can do like echo file is $X, done. And you know, it's just showing me all of those files by executing that echo command one file at a time.
That only happens in your path, correct? Oh, sorry, not your path. That only happens in the current directory that you're in?
Just in the current directory. And also some of these are actually directories themselves. So Django and Hello are directories, and I can't really distinguish that here. Some shells have a way to use a wildcard that only matches regular files and not directories and that sort of thing. But that's one way to use a for loop.
So now that we've gone over the basics of shell scripts, what are some more advanced things that we can do with it? Something that could actually be put to use on a daily basis?
Let's do a practical example like that. And I keep going back to image processing. We did image magic as a theme of an episode. And it's something I have to do pretty often. So for example, let's say that you're creating a little game application, either a web app or on a mobile phone or something. And you find or create a set of playing cards, like the faces of cards. And you need to use them at different sizes, depending on whether this is on a tablet or on a phone device or something like that. So the first thing is I have this zip file here, and I'm going to unzip that. So probably you have a command called unzip to deal with that. If not, you know how to look for it in the package manager and install that. So I'm going to unzip, and it's asking me if I want to overwrite some files that I forgot to delete from the last time I did this. So I'll say, yes, that's okay to overwrite all of those. What's a little weird here is that it created a subfolder called playing cards where it put a bunch of stuff, but it also created this folder Mac OS X, and we don't need that. It's just when you zip something on a Mac, you often get these extra files which can hold some Mac-specific settings in them, but we don't care about any of them right now. So I'm going to go into my playing cards folder, and in there I see two subfolders for PNG format or SVG. So we'll go into PNG. And here's just a big pile of PNG files for the faces of all these different cards. So if I go and look at those using my EOG viewer, for example, that's what they look like. And these are 500 by 7 something pixels. So that's the size. Now, if I want to use them at different sizes, let's say I want to resize them at like 50% and 33% and 25%. And I want to just batch creating all of those assets at those different sizes. So let's create a script called resize.sh. And we'll start with the hash bang and set -e so it stops on error. And then I'm going to create a little loop for the sizes that I want. So 50, 33, and 25. That size will get put into the z variable, and then I can do stuff with that. So I'll say creating $z. So I have a little status message, because a lot of the other commands I'm going to do don't really output anything if they're successful. So at least I'll be able to see those messages. Next, let's do a makedir. And I want to makedir cards $z. So it'll say cards 50 or cards 33 or whatever. And in case that directory already exists, I'd like it to keep going. So the -p option, I think we learned this having to do with creating parent directories. That will also have the effect of if the directory already exists, it just moves on. Then I want to make a copy of all of the PNG files from the current directory and move them into cards $z. Finally, I'm going to use Mogrify at a geometry specified by $z %, so 50%, 33%, whatever, and apply that to all of the PNG files in the subdirectory. So this way it'll leave the PNG files in the current directory, they'll stay at full size, and I'm creating copies of them to shrink them. One thing I forgot up here on my for loop is a do, and then down here I have the matching done. So I think that looks all right. We're going to try it out. So write that file and save and exit. And let's try resize.sh. Oh, forgot one thing. That
Chmod.
chmod plus x. Yep. So there we go. So now it should be able to execute that script. And it'll go through the 50, the 33, and the 25. And as it did that, it created these subfolders here in blue. And we can browse those the same way. So here are the small images. They ended up at 125 by 182. And let's do 33. They're at 165 by 240. So we have our assets now resized in a couple of different ways. And that's just a very practical example of using a script and a for loop and image magic and copy and a lot of things we've learned so far.
So today we learned about shell scripts as well as permissions. We also touched base on environment variables. We also learned about for loops and how to incorporate them into our scripts. Thanks for joining us.
Yeah, see you next time.